Okay, so we've had a brief look at the rules of indices and how to manipulate fractions that involve indices or powers. So the next thing is to solve equations that involve indices. So for instance, suppose we're asked to solve the equation 3 to the power of x equals say the square root of 3 over 27. So we want to find what number must x be so that the left hand side is equal to the right hand side. What we always do, so the cardinal rule here is bring everything, every number that we have, to a power of the same number. So here, the obvious choice is 3. That's obviously 3 to a power. That we should be able to write this as 3 to a power, and the 27 we should be able to write that as 3 to a power. So step number 1 is bring everything to powers of the same number. Step number 2 is get, we'll say whatever it is, a to the power of something equal to a to the power of something else. And then step number 3 is set the two powers equal. So these last two steps will make sense in a second when we go through this question. So what we need to do here, we have 3 to the x equals, we need to write this square root of 3 over 27. We need to write root 3 as a power of 3. So the square root of 3, we hopefully remember from the last time, is 3 to the power of a half. And 27 is, it's not 3 to the power of 9, it's 3 by 9, but we want to write it as a power. So 27, like to figure out how to write something as a power, we'd say 3 by 3 is 9, so that's 3 squared, by another 3 is 27. So we have to multiply 3 by 3 by 3 to get 27, so it's 3 to the power of 3. Okay, so now we've step 1 done. We've brought everything to powers of the same number. Everything now here is a power of 3. So that's step 1. Step 2 says we want to get just 3 to 1 power on the left. So we have that, 3 to the power of x. So 3 to the power of x. And on the right hand side, we just want to get 3 to 1 power. So the question is, what do we need to do with these two powers? And hopefully we remember that what we need to do is subtract them. So that's 3 to the power of a half minus 3. So we have 3 to the power of x equals 3 to the power of minus 2.5. So we'll say minus 2.5. And then the last step is set the two, that should say set the two powers equal. Sorry about that. So set the two powers equal. So if 3 to this power is the same as 3 to this power, then those powers have to be the same thing. So 3 to a number is the same as 3 to this number, then that and that number have to be the same. So therefore x is equal to minus 2.5. That's it. Okay, so that's the basic idea. The questions get a little bit more difficult, but we're going to follow the same basic idea. So we'll put that there, and we'll occasionally come back to, let's number them, 1, 2, and 3. So bring everything to powers of the same number, get that number to a power is that number to another power, and then set these two powers here equal. All right, because if these are the same, then whatever's in this box has to be the same as whatever's in that box. All right, so let's have a look at maybe a slightly more difficult question. So 9 to the power of 3x plus 1 equals 81 all over, let's say, the cube root of 3. So again, this is one involving 3's. Maybe we'd be better off without one involving 3's, but anyway, we'll give it a bash. 9, I'm looking at 9, 81, and 3, so they can all be written as powers of 3. So the 9 there, that's going to be 3 squared. And because it's 9 to the power of 3x plus 1, this is going to have to be 3 squared to the power of 3x plus 1. Okay, that 3 squared there is the same as that 9, so I still have to put the same power on it. Alright, I don't want to mess with the equation, I just want to write it in a different way. So the 81 now, 3 by 3 is 9, by 3 is 27, by 3 is 81. So 1, 2, 3, 4, that's 3 to the power of 4. And the cube root, we hopefully remember, is a power of a third. Alright, so that's step number 1 done. So step number 1, bring everything to powers of the same number, done. Step number 2, get, we say in this case 3, so 3 to a power equals 3 to another power. So we don't have that on either side yet. Here we have 3 squared to another power, so we hopefully remember we have to multiply the two of them. So it's 3 to the power of 2 times 3x plus 1. So those two numbers multiplied. On the right hand side, if we're dividing, we have to subtract these two powers. So we get 4 minus 1/3. So to just simplify that, that's 6x plus 2. And this is 3 to the power of 4 minus 1/3 is 3 2/3. Or to write it is 11 over 3 to write it as a top heavy fraction. So 3 to this power is equal to 3 to that power. And that's step number 2 done. Alright, so here we go, step number 2. And the third one said that now that we've a to a power is a to another power, then those two powers, the two numbers in the boxes, have to be the same. So we're going to set these two powers equal, so that has to be equal to that. So 6x plus 2 equals 11 over 3. If we minus 2 from both sides, we end up with 6x plus 2 minus 2, so it gives you 0, so they're gone. Over here we have 11 over 3 minus 2, so we end up with 5 over 3. And to get rid of that 6, we need to divide by 6. So dividing by 6, we get x equals 5 over 3 divided by 6, which is 5 over 18. So that there is our answer. So the solution to the equation right back up at the top here is x equals 5 over 18. Alright, so just to run quickly through the 3 steps again. Step number 1, write everything as powers of the same number. Done. Step number 2 was to try and write everything as 3 to a power is 3 to another power. So just have one power of 3 on the left. So here we have 3 to a power all to it, so that's too complicated. Let's just get it as 3 to some big power. And on the right, just have 1 3 to some big power. So that's done at this stage. And then step number 3 is set the two powers equal. So if 3 to the power of this box is 3 to the power of this box, what's in the boxes has to be the same. So you set it up, 6x plus 2 is 11 over 3, go and solve the equation. And that's it, 5 over 18.